In the name of Almighty God, I am Master Sankosh, and today I want to talk about Z80 microprocessor. The Z80 is an 8-bit microprocessor designed by Zilog that played an important role in the evolution of early personal computing. And what about comparison with the 8080? Faggin designed the instruction set to be binary compatible with the 8080 so that the most 8080 code, notably the CP/M operating system and Intel's PLM compiler for 8080 as well as its generated code, would run unmodified on the new Z80 CPU. The Z80 offered multiple improvements over the 8080. The first one is an enhanced instruction set including a more logical, comprehensible, and readable system of assembler instruction memories. More flexible 16-bit data movement, load or LD instructions, crucial including the stack pointer (SP). More flexible addressing modes for input-output to external peripheral ports. Single-bit addressing of all registers and memory including bit testing. Shifts rotates on memory and registers other than the accumulator. Subtraction supported for BCD arithmetic, rotate instructions for packed BCD number strings in memory, 16-bit subtraction and 8-bit negation, program looping, program counter or PC relative jumps, blocks copy, block input output IO, and byte search instruction. An overflow flag with better support for signed 8 and 60-bit arithmetic. Neo 4 and IV index registers with based positive offset addressing mode and a better interrupt system. A more automatic and general vectorized interrupt system mode 2 primarily intended for Zilog's line of counter timer and DMA and communications controllers, as well as a fixed vector interrupt system mode 1 for simple systems with minimal hardware, with mode 0 being the 8080 compatible mode. A non-maskable interrupt or NMI, which can be used to respond to power down situations or other high priority events, and allowing a minimalized Z80 system to easily implement to uh, a two-level interrupt scheme in mode 1. A complete duplicate register file which could be quickly switched to a speed-up response to interrupts such as fast asynchronous event handlers or multitasking dispatcher. Although they were not intended as extra registers for general code, they were nevertheless used that way in some applications. Less hardware required for power supply, clock generation, and interface to memory and I/O. Single 5-volt power supply, the 88 needed negative 5 volt to positive 5 volt and positive 12 volt. Single phase 5 volt clock, the 88 needed a high amplitude 9 to 12 volts non-overlapping two-phase clock. Built-in a DRAM refresh, which would otherwise require external circuitry. The 88 had been designed before DRAM was widely used, and the common SRAM didn't need refresh. By the mid 1970s, DRAM had largely replaced SRAM for most roles, but using DRAM with the 8080 required additional external circuitry. Implementing this internally in the Z80 reduced the complexity and cost of a complete system. Non-multiplexed buses, the 8080 had state signals multiplexed onto the data bus. A special resets that zeros only the program counter so that a single Z80 CPU could be used in a development system such as in circuit emulator. And what about the success in the market? The Z80 took over from 8080 and its offspring, the 8085, in the processor market and became one of the most popular and widely used 8-bit CPUs. Some organizations, such as British Telecom, remained loyal to the 8085 for embedded applications, owing to their familiarity with it and to its on-chip serial interface and interrupt architecture. Likewise, Zenith Data Systems paired the 8085 with the 16-bit Intel 8088 in its first MS-DOS computer. The Zenith Z100, despite having previous experience with its pioneering Z80-based HitKit H89 and Zenith Z89 products. However, other computers were made integrating the Z80 with other CPUs. The RadioShock TRS-80 Model 16 with a Motorola 68000, the DEC Rainbow with an 8088, and the Commodore 128 with MOS technology 8502. Zilog was later producing a low-power Z80 suitable for the growing laptop computer market of the early 1980s. Intel produced a CMOS 8085 used in battery-powered portable computers such as Kyocera's design laptop from April 1983, also sold by Tandy as TRS-80 Model 100. Olivetti and Nick. In following years, however, CMOS versions of the Z80 from both Zilog and Japanese manufacturer would dominate this market as well in products such as Amstrad NC100, Cambridge Z88, and Tandy's own WP2. Perhaps a key to the initial success of the Z80 was the built-in DRAM refresh, at least in markets such as CPM and other office and home computers. Most Z80 embedded systems use a static RAM that don't need refresh. It may also have been its minimalistic two-level interrupt system, or conversely, its general multi-level daisy chain interrupt system useful in servicing multiple Z80 I/O chips. These features allowed systems to be built with less support hardware and simpler circuit board layouts. However, others claim that its popularity was due to the duplicated registers that allowed fast context switches or more efficient processing of things like floating point mask compared to 8-bit CPUs with fewer registers. The Z80 can keep several such numbers internally using HLHLDAD and BCBC as 32-bit registers, avoiding having to access them from a slower RAM during computation. For the original MOS design, the specified upper clock frequency limit increased successively from the introductory 2.5 MHz via the well-known 4 MHz Z80 up to 6 MHz Z80B and 8 MHz Z80H. An NMOS version was produced as the 10 MHz parts beginning in the late 1980s. CMOS versions were developed with specified upper frequency limits ranging from 4 MHz up to 20 MHz for the versions sold today. The CMOS versions allowed low-power standby with internal state retained having no lower frequency limit. The fully compatible derivative HD64 180, Z180, and EZ80 are currently specified for up to 33 MHz and 50 MHz respectively. And what about the Z80 design? Programming model and register set. The programming model and register set of the Z80 are fairly conventional, ultimately based on the register structures of the data point 2200. The Z80 was designed as an extension of the Intel 8080 created by the same engineers, which in turn was an extension of the 8008. The 8008 was basically a PMOS implementation of the TTL-based CPU of the data point 2200. The 2200 design allowed 8-bit registers H and L, high and low, to be paired into a 16-bit address register HL. In the 8080, this pairing was added to the BC and DE pairs as well, while HL was generalized to allow use as a 16-bit accumulator, not just an address register. The 8880 also introduced immediate 16-bit data for BCD, HL, and SP louds. Furthermore, direct 16-bit copying between HL and memory was now possible using a direct address. The Z80 orthogonalized this further by making all 16-bit registers pair, including IX and IREG more general purpose, as well as allowing 16-bit copying directly to and from memory for all of these pairs. The 16-bit IX and IREG registers in the Z80 are primarily intended as base address registers where a particular instruction supplies a constant offset that is added to the previous values, but they are also usable as 16-bit accumulators, among other things. A limitation is that all operand references involving IX or IY require an extra instructions prefix byte, adding at least 4 clock cycles over the timing of an instruction using HL instead. This sometimes makes using IX or IY less efficient than a method using only the 8080 model registers. The Z80 also introduced a new signed overflow flag and complemented by the fairly simple 16-bit arithmetic of the 8080, with dedicated instructions for signed 16-bit arithmetic. The Z80 80-compatible registers A, F, B, C, D, E, H, L are duplicated as a separate register file in Z80, where the processor can quickly infer T states at least possible execution time for any Z80 instruction. Switch from one bank to other bank. Thank you so much for watching my video until the end. Also, you can download the Z80 CPU circuit from my GitHub to the address of github.com/masterscript.